All right, Algebra 2 people, let's do this. So we have an exponential modeling video coming your way. Now, you have done modeling for many different types of equations before. We've done quadratic, cubic, quartic, whatever we needed before. Back in the day in Algebra 1, you did it with lines or linear. So a quick recap on what we used to do. And then I'm going to show you how to use your calculator to do it. And then we're going to do a couple by hand, and we're good to go. So the first thing you have to do is determine which type of model it is. Now, you probably remember us doing common differences. From -3 to -1, we have to add 2. From -1 to a +1, we have to add 2. From 1 to 3, we have to add 2. 3 to 5, we have to add 2. And since they all have a common difference, that is a linear function. And then we tried it again, where to get from -3 to 0, we had to add 3. 0 to 5, we add 5. And 5 to 12, we're going to add 7. And then, of course, 12 to 21, we're going to add 9. And we have different jumps. So then you do it again with the first set of jumps. From 3 to 5, we add 2. 5 to 7, we add 2. 7 to 9, we add 2. So it took 2 steps. And if it takes 2 steps, then that was quadratic. So those are just some things that we did back in earlier units. But now we're talking about exponential modeling. So you still sometimes will have to determine if it even is an exponential equation. So if you were to try the jumps with sums first, 3 to 6 would go up 3, and then we'd go up 6, and we'd go up 12, and then we'd go up 24, and we already know that that's not going to work. So we try it again. To get from 3 to 6, we go up 3. From 6 to 12, we go up 6 again. 12 to 24, we go up 12 again. And we notice that it's not getting any closer. So now you have the opportunity to check to see if it's actually an exponential equation. And to do that, you actually multiply. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. And then we notice that this is actually doubling each time. And when you have a common multiplier to get from one to the next, that means we have an exponential equation. But then it's pretty much the same thing. We just have to use a regression in our calculator. So if you forgot how to do that, make sure you have your graphing calculator handy, and I will remind you how to do it. The first thing you have to do is press the Stat button. And the first thing we need to do is edit a list, so number 1. Now remember, in L1, you type your x's, so we have 1, 2, 3, 4, 5. So we're just going to enter those into L1. And in L2, we are going to list our y values. So we have 3, 6, 12, 24, 48. Okay, and after you have it all entered in, what we need to do is we need to go to a regression. So this is where we're going to quit out, and you press Stat, slide over to Calc, and we have to go find the right regression. So linear regression is what we would use for the first example. Quadratic regression is what we use for the second example. But now you have to go all the way down until you can find an exponential regression, which in this case is 0. So we have an exponential regression. And of course, it's going to ask you for L1 and L2. If you always use L1 and L2, you won't have to change anything with that. We don't need to store it anywhere because we just need the equation. So we go down to Calculate, and we click Enter, and it gives us the equation. So our A value is 1.5, our B value is 2, and it's in the form A times B raised to the x power. So all we have to do now is write the equation. So our exponential equation is y is equal to A is 1.5 times our B value is 2 raised to the x power. Okay? That's how you use your calculator to find an exponential model. All right? So we can also do it by hand. And we need 2 points to do it by hand. So if you wanted to do that table by hand, you would just have to pick 2 of the points after you determine that it is in fact an exponential model. And I'll show you what to do. So we know the exponential equation is y is equal to ab to the x power. And what we're actually going to do is use a system of equations to do it, not system of linear equations. These are not linear. But we're just going to use substitution to do it. So what you do is you take your points and you substitute them in for x and y. So 1 comma 6 is going to give us the equation 6 is equal to ab raised to the first power. So all we did was substitute in x and y. The ab will stay. And then we're going to substitute in the second point. So 24 is equal to ab raised to the third power. And now we have 2 equations. Now, just like substitution of linear equations, you need to get a variable by itself. So what you want to do is you want to get a by itself. So we're just going to manipulate this, and to get a by itself, we would just divide both sides by b to the first power. So a is equal to 6 over b to the first power. And substitution rules, we're just going to substitute that into a of our other equation. So the 24 stays, that's equal to, and now we're going to use our a value, which is 6 over b to the first power, and then times b cubed. Now, since we have a fraction, you could just write it on the top because b cubed is the same as b cubed over 1. And now you just have to use a little bit of simplifying and solving, and you're done. So we have b cubed on top, b to the first on the bottom. That's going to simplify to just b squared. So we have 24 is equal to 6b squared. Divide both sides by 6. And we have 4 is equal to b squared. Square root both sides. And we end up with b is equal to 2. Now that we have b, we just have to go back and substitute it all the way into this equation. So we have a is equal to 6 over our b value of 2. So we know that a is equal to 3. So from here you just have to write the equation. So your final equation after all that work is y is equal to our a value of 3 times our b value of 2 raised to the x power. Okay? Now you might be wondering, do I have to do all that work? Well, you could just type in these 2 coordinates into L1 and L2 and find an exponential model. However, if you are told on a quiz or a test that you have to show all work and do it algebraically, now you know how to do it. But no one ever said you can't check with your graphing calculator. Okay? So the next example is the same thing. I would like you to just pause the video to see if you can work yourself through one of these exponential models. Click play as soon as you're ready, and we'll be good to go. So the first thing you have to do is write your equation. So you should have 8 is equal to ab to the third power, and you should have 64 is equal to ab to the 6th power. And then you should get a by itself. So a is equal to 8 over b cubed. So from there, we're going to substitute a into that guy right there. So we have 64 is equal to 8 over b cubed times b to the 6th power. That's going to simplify. So we just have 64 is equal to 8. B to the 6th over b cubed is just b cubed. Divide both sides by 8, and we have 8 is equal to b cubed. And take the cube root of both sides, or raise both sides to the 1/3 power, and we end up with b is equal to 2 again. Now, don't get comfortable. B does not always equal 2. That's just a coincidence here. So now that we know b is equal to 2, we're just going to go back in and find a. So that's going to be a is equal to 8 over 2 cubed. Last time I checked, 2 cubed is 8. So a is equal to 8 over 8, which is 1. So now our equation, our final answer is y is equal to 1 times 2 to the x power, also known as y is equal to 2 to the x. You do not have to multiply by 1 if you do not want to. All right, so that's it for exponential modeling. Again, if you have to show work, please make sure you know how to do these last two questions. However, if you are just allowed to use your graphing calculator, then you would type those coordinates into L1 and L2 just like we did the chart above. This is Longo and I'm out. See you, bye.